Hey everybody, in this video I want to talk about multi-agent systems. So just to give a brief introduction, we all know that large language models are used in chatbot applications like ChatGPT. And in ChatGPT, when you ask uh, a specific question, you give the model a specific prompt, you get a response from the model. Um, And basically, when you're interacting with a large language model, essentially, uh, you know, you are interacting with a very intelligent model that is responding to your prompts. However, agent are one step above, typical chatbots because uh, unlike rudimentary chatbots, an agent is part of an application that can perform a specific task for you. So, for example, if you have an agent that sits on top of your inbox, and the responsibility of an agent that you've given to it is essentially filter out which emails are of utility and value and which emails should be in the junk files. So that particular agent can actually parse through your inbox and filter out uh, emails that are of value and every other email that is, that does not uh, have any consequential value and it should be in the junk folder. So that is one of the examples where we can leverage an AI agent. So usually an AI agent can be, if we look at the anatomy of an AI agent, it consists of several different parts. So obviously, an AI agent is powered by a large language model that acts as the brain for an AI agent. The second thing that an AI agent has essentially is the role that it has to perform. So when we build an agent, we give it a specific role, and we ask an AI agent to perform that specific role. And sometimes that can involve taking an action, making a decision, performing a specific work, etc., etc. And to make sure that the agent has all the wherewithal to perform that specific task, we give it, uh, you know, a specific context of the environment, and we give it external tools that it can use to perform its task. Now, there are different scenarios where having just one single agent won't suffice if, there are various different facets to a particular task. So as I mentioned, unlike the case that I just presented, where you have an AI agent that sits on top of your mailbox and it basically cleans up your inbox, that's a pretty straightforward task that you can, do it with one agent. But what if the task is a little more complicated and it has, various different subtasks to it? You can, easily compartmentalize the different, subtasks that, make up the whole primary task. So, if I have to really think of, a very interesting example to, elucidate, a scenario where one agent might not suffice because you cannot really pinpoint and give it a holistic, task that encapsulates the different subclass which are part of it. So let's just say, you know, you want to, book a hotel, uh, you know, over the weekend, and you have a certain price range. You want to book it for, you know, a certain group of people. So in that particular case, you want, essentially to look up for hotels that have the best prices that, suit your need. And you also, want to get a bunch of options so that, you can make the appropriate decision based on that. So this is a pretty, it's a pretty long-winded task, as in comparison to, just making a specific decision. Here, you have to first, go through different booking websites, scrape through, sort of the different options, choose the best option according to your need, And then out of the myriad options, you have to choose what is the best option that, I want to go ahead with. So in this case, you can easily, synthesize in your head that it's not a straightforward one-off task. You have to sort of compartmentalize this into multiple subtasks. So in this particular scenario, we can leverage something, uh, you know, we can leverage something akin to a multi-agent system. Now, essentially, when we speak about, multi-agent systems, there's always this misconception that, you know, if we have a bunch of agents in a given environment that are doing a specific task that is assigned to them, that in and of itself is a multi-agent system. That is not true, actually. In a multi-agent system, there has to be some form of communication and coordination between the agents. So if you have a group of agents that are performing a specific subtask that is part of a broader goal, and those agents are communicating with each other, you know, given any paradigm or any framework, then that particular modality is referred to as a multi-agent system. So just to run down some of the things that we discussed. So if you have a single agent, you always give it instructions, you give it external tools, and the engine or the brain is powered by a large language model. Uh, the agents fundamentally need context of your environment, uh, and they have to interact with as I mentioned, external tools. So sometimes these external tools can be in the form of API. So one of the common APIs that we give our AI agents is the Surf API to scrape through the web. And in case of a multi-agent system, you have something akin to an orchestrator that sort of manages the functioning and the operation of the various worker agents that are part of the multi-agent framework. And as I just discussed, in a multi-agent system, the agents are not working in isolation. They have specific subtasks assigned to them, but that is part of a broader goal. And in a multi-agent system, agents coordinate with each other to accomplish that particular broader goal. Uh, there are a couple of different uh, types of you know roles that an agent can play within a broader multi-agent system or a multi-agent framework. So I will get to what are the different ways in which we can establish communication protocols within a multi-agent system. But in a multi-agent system, you can have an orchestrator agent, which acts as a dispatcher. It receives instructions, divide them into subtasks. It assigns different jobs to worker agents. You have the worker agents that those agents that have a specific role assigned to them within a broader objective, and their goal is to basically go ahead and accomplish that task. Then you have a router, agent, and the role of the router agent is to basically, evaluate the intent and direct the traffic towards a worker downstream. And then you have a planner that is responsible for architecting the journey and coming up with a comprehensive list of steps that needs to be taken to accomplish a certain task. So those are the different archetypes that AI agents demonstrate within a system. Now these are certain communication protocols that we have that we can use in a multi-agent framework to make sure that agents are communicating with each other. So you have a sequential paradigm where uh, agent A performs a specific task, then gives the handoff to agent B. Agent B gives a handoff to agent C. Then you have a form of parallel execution where agent B and agent C are working in parallel, and sort of agent A becomes the orchestrator that is managing it. Then you have the router where you have a router agent that is kind of directing traffic and giving the task to specific worker agents. And then you have a hierarchical framework where you have an orchestrator, and you have sub agents that directly communicate to the orchestrator. The difference between a parallel communication protocol and a hierarchical communication protocol is that in a parallel communication protocol, it's not necessary that B and C are worker agents that are supposed to reach out and always report to agent A. But in a hierarchical framework, you have an orchestrator that takes care of you know the orchestrator essentially acts as a manager, and it delegates tasks, and the sub agents, they communicate back to the orchestrator, so everything sort of goes through the orchestrator. And as I mentioned, in the AI, in sort of the broader, agentic framework, when you will develop, multi-agent systems, you will have your infrastructure layer, you will have your guardrails, basically to make sure that, you know, the agents are, functioning within certain guardrails, within certain contours. You have the identity layer for, authentication and authorization, and you have the, infra layer for security measures. So one of the examples that I have sort of developed is so I actually listen to a bunch of really interesting podcasts around artificial intelligence and machine learning, and sometimes I listen to podcasts either while I'm taking a walk, or I'm cooking, or I'm making my morning coffee, or sometimes when I'm doing something that is really cumbersome, and I want something to play in the background. So in those scenarios, I just put on a podcast and I start listening to it. But sometimes some podcasts are extremely dense, and because my act of listening is quite passive in that particular context, I'm not able to retain as much information. So whenever someone releases, or a content creator releases a new podcast, and I know that it's going to be a fascinating listen, but also there will be a lot of extremely rich and interesting information embedded in that podcast. I really want to I really want something akin to a debrief to either come to my email or my WhatsApp, so that I can just read through it once again, just to revise a lot of the interesting concepts around what was discussed in that podcast. So one of the interesting use cases that I curated was uh, this particular dashboard where I have a multi-agent framework that is responsible for you know extracting the content from the latest video that one of the YouTube channels that I like, has posted. And from that, what the multi-agent system does, it creates a debrief, a very brief summary. It, sort of parses through a bunch of, topics that were discussed. And if there is a paper that was explicitly discussed, and, it basically, gives the link of that paper. So one of the, sort of channels that I really like is Machine Learning Street Talk. And when I ran the workflow, uh, as you can see, this this was the latest episode that was launched. It was the AI Progress. Everyone is Misreading by Beth Barnes and David Reen. And it basically gave me a very, very, interesting, short, concise debrief of that. So this was one of the use cases that I prepared. Uh, there were no papers that were discussed, so it did not retain anything. It actually discarded all the possible options. Uh, so this was one of the use cases, and as you can see, the external tools are the YouTube discovery tool and the arXiv matching tool that were given to the agents to gather specific and relevant context, and sort of parse through the content and extract relevant information. One another thing that I forgot to tell you is when you're developing a multi-agent framework, there are a lot of different, libraries that you can leverage. A very common one that developers use is LangGraph, because LangGraph sort of allows you to have more control over uh, you know, the how the sequence flows from one agent to the next. But sometimes, you want a little more flexibility and you want agents to have more autonomy to, decide in which direction they want to go. So in so I used True AI, which is another framework to develop this multi-agent system. And another, interesting but rather rudimentary example that I have is that of a blog generator. Now, I have a Medium blog that I write, and sometimes when I think about, okay, what topic shall I write about next, and I just need like a not a very detailed blog, but I want an idea and I want to build on top of that idea. So what this particular multi-agent system does is it basically you know parses through my medium blog history, then it selects a particular topic that can perfectly sort of be the topic of the next article, then it plans a writing brief, it generates an article, it basically does a few checks and references for quality, and then it assembles a blog. Now, sometimes I love the quality. Sometimes I want to sort of add a little bit more, but it gives me like a good starting point to think about what is the next topic that I want to write on. So I hope you guys got some value from this video. Thank you so much for listening.